Welcome. So we're just going to work through question 1 here of exercise 8G. Let's see what it says and see how we go with it. Okay, so it says a body starts from the origin O and moves in a straight line. After t seconds, its velocity v centimeters a second is given by this. Find its position x in terms of t. So notice how they've started off by giving us the velocity, not by giving us the equation for the position of the particle as they did in exercise 18F. So what they want us to do here is to work backwards. They've given us the velocity and they want us to find the position of x in terms of t. They want us to find that position equation. So how are we going to do that? Well, to go from this to our position equation, we're going to have to integrate. So let's come here. Oh, that's pretty. Let's see if I can find a nicer pen than that. So we've got a here, and what I know is I know that the velocity is going to be represented by 4t minus 6. Therefore, if I want to find what my equation of the position is going to be, it's going to be, I'm going to anti-differentiate 4t minus 6 dt, because I'm anti-differentiating with respect to t. Then remember the way that you do this, you add 1 to the power, you divide by that, and then this will just become 6t. And then also remember you have to plus on a constant there. So that means I'm going to end up with 2t squared minus 6t plus c. Now, once I've done that, I need to figure out what c is. And in fact, they've given us enough information in the question to figure that out. It's because it says the body starts from the origin. So that means when t is equal to 0, I'm at the origin. So in other words, I know this. I know that x of 0 is 0. Because I know when t is 0, it is at the origin. So therefore, I can use this to help me figure out what I need to do here. Because I know that this here is x of t, because I differentiated it. So that means I can say, when this is 0, this will be 0t minus 6, 0 plus c. That will go away, that will go away, 0 will be equal to c. So that means it's actually just going to be this, 2t minus 6t. That's going to be my answer, because c is equal to 0. And we're done. Let's now go on to part B. Part B says, find its position after 3 seconds. All right, so to find the position after 3 seconds, I'm going to go, what is x of t? It's 2t squared minus 6t. And now I'm going to say, let t be equal to 3. So I'm going to, x of 3 is going to be 3 squared minus 6, 3, which is going to be 2 to the 9 minus 18, which will be 18 minus 18, which is 0. The particle is at the origin. Perfect. I do have my CAS there, and I do hope to use it, but we'll see how things go. The next question says, find the distance traveled in the first 3 seconds. Okay, find the distance traveled in the first 3 seconds. What I'm going to have to find here first is whether or not I have any stationary points. So let me come here. What I'm going to do is I'm going to say v of t is equal to 0, solve for t. You know, I might do this without the CAS. I might just keep going. So I'm going to take my velocity equation. I'm going to set it equal to 0. I then am going to solve it. 6 on 4. T is equal to 3 on 2. Perfect. So that means when t is at 1.5 seconds, I'm going to get a stationary point. Let's find where that happens. V of 1.5 or 3 on 2, because I'm not going to use my CAS. I'm going to have to do this like that. Oh, sorry, I'm not going to go V of 3 or 2, am I? I'm going to use my position equation to find where this occurs. So I'm going to go X of 3 on 2. My position equation is 2. Oh, this is going to take forever. 3 on 2 squared minus 6. 3 on 2 equals 2. 9 on 4 minus 18 on 2, which is going to be 18 on 4 minus 18 on 2, which will be, I can halve both of these. This will be 9 on 2 minus 18 on 2, which means I'm going to be left with negative 9 on 2. I wish I used my CAS. Negative 9 on 2, which is going to be negative 4.5 centimeters. And remember, that means 4.5 centimeters to left of origin. It is at rest. All right. Now that's important for us to figure out. I've got that point of rest there. So now with that information, I can draw myself a little diagram here just to help myself. So I'm going to do this. Whoop, let's try that again. Do that. 0. Now where am I? Where am I? Where am I starting from, rather? Find that. Find its position. I need to find its initial position. I haven't been... Oh, no, I know this initial position. The body starts from O. Yeah. We know its initial position is here. That's where I'm starting from. And then at 1.5 seconds, I have a stationary point at 4.5 centimeters to the left of the origin. So here, 4.5 there. This is going to be at rest at t is equal to, what did I say? 1.5, right? This is when t is equal to 0. Now I need to find, the question was actually saying how far does it travel in the first 3 seconds. So I need to find the position of 3 now. So I'll come here and I'll go, what is x of 3? That's going to be 2. Oh, wait. Oh, I forgot a square there. My apologies. That should be squared. 2t squared minus 6t. I forgot that. But that's all good. I used it correctly for the other ones, which is lucky. All right. What was I doing again? I'm subbing 3 into this. Squared minus 6, 3 equals 2 to the 9 minus 18, which is 2 9s are 18 minus 18. What? I go back to the origin. This is also the end. This is when t is equal to 3. So if my calculations are correct, and I believe they are, I'm going here, I'm going around, and I'm coming back. So that means my total distance will just be 4.5 plus 4.5. My total distance should be 9. Very cool. So you can see how much working this is taking. Nine centimeters. And let's highlight that as well. Okay, the next one. D, what is its average velocity in the first 3 seconds? A, B, C, D. Its average velocity in the first 3 seconds. Remember, the way that you find the average velocity is the change in position. Over the change in time. Now, it's the velocity over the first 3 seconds. So its change in position will be x of 3 minus x of 0, 3 minus 0. Now, let's just double check that I don't mess this up. We know what each of these are. T of 3 is 0, and T of 0 is 0. My goodness, what is going to happen here? So this is going to be 0 minus 0 over 3, which will be 0. My average velocity is 0. Spectacular. Yep, average velocity of 0, 3 is 0. I'm going to say 0 centimeters a second. Why not? Because I didn't change in position. So even though it moved, my average velocity isn't able to capture that movement in any way. The average velocity doesn't seek to do that. It's doing something else. But the average speed, now this it will be able to tell me. The average speed, remember, is the change in distance. A, B, C, D, E. Average distance. Sorry, average speed. My goodness. Is distance over time. Okay, the distance traveled, I know, is 9. The time is taken is 3. It's going to be 3 centimeters a second. I don't know why I'm all doing this in red, but it's done now. That will be my answer, 3 centimeters a second. And that's how you do this question. A really fantastic question that is getting you to realize that sometimes your average velocity, if you were to look at that, it looks like it's not moving at all, but it is. It's going back and forth, but it's going back to where it started from. So my average velocity, because it's change in position over the change in time, just reads as 0. But my average distance, because it's the total distance, it is able to capture the amount I'm moving. Hopefully you found this helpful in going through this question. I'll see you in the next one.